Hi everyone, today we are going to learn how to determine the empirical and molecular formulas. In this video, I'll go over how to do that. And so in the past, we learned about the molecular formula, and I would tell you, hey, simplify this to the empirical formula. And so remember that the empirical formula is going to be basically your simplified formula, whereas the molecular formula is the actual number of atoms. So we're going to be following these 4 steps to find the empirical formula. I'll do 2 examples for that, and then we'll do 1 example for the molecular formula. So here the question says a compound contains 25.9% nitrogen, 74.1% oxygen. What is the empirical formula? So we're just going to go through these steps one by one to solve this problem. So step 1, convert percents into grams. So this is going to be the easiest step here. All we have to do is change that percent into grams of nitrogen. We're basically assuming that we have a 100-gram sample, and so that allows us to simply turn the percent directly into grams. Step 2, convert grams to moles. So here I'm going to set up a conversion factor so I can do these 2 conversions. I'm going to convert these grams now into moles. So moles go on top. The molar mass of nitrogen is about 14 grams per mole. For oxygen, it's about 16 grams per mole. So I take 25.9 divided by 14, and I get 1.85 moles of nitrogen. Meanwhile, I do 74.1 divided by 16 to get about 4.63 moles of oxygen. All right, step 2, check. Step 3 here. Divide each molar quantity by the smallest number of moles. So the smallest number of moles is going to be this 1.85. I'm going to divide both of these numbers by 1.85. I get 1 nitrogen and about 2.5 oxygens. So now we should be able to write our formula, and if we try, we would write NO2.5. Now if you're looking at that thinking, well, that doesn't seem right, well, that's true. We can't have half of an oxygen atom, so this is actually incorrect. We're going to have to see what that last step is here. So step 4, multiply each part of the ratio by the smallest whole number. That's going to convert everything to whole numbers. So here, if you have 0.5, half of something, the smallest number that's going to turn that into a whole number is if I multiply everything by 2. So here I end up with 2 nitrogens, 5 oxygens. With that, I can now write the empirical formula. It's going to be N2O5. Okay. So there you have it, 4 steps to find the empirical formula. Check, check, check. So let's go ahead and do another example, and we'll just follow the same exact steps. So step 1 is already given to us because they've already given us grams here. We don't have to change that. So we'll just start with step 2, converting those grams to moles. So since we're using the same chemicals here, the numbers are going to be very easy. We've got our molar quantities. Now we want to divide by the lowest number of moles. We get 1 nitrogen and 2 oxygens. Because these are whole numbers already, we don't need to do that last step. So our formula is simply going to be NO2. Okay? So that's how we find the empirical formula. Make sure you review these examples if you're having trouble with this kind of problem. All right, example 3 is how to find the molecular formula. So it says the compound is found to have an empirical formula of NO2. All right, we just found that empirical formula. The colorless liquid has a molar mass, and this is the molecular molar mass, of 92 grams per mole. Determine the molecular formula. So the steps are different here. The first step for molecular formula, we want to find the molar mass of the empirical formula. So let's go ahead and do that. So when you look at your periodic table, we break down NO2. That's 1 nitrogen, and we've got 2 oxygens. 14 plus 32 is going to give me 46 grams per mole. Step 2, divide the actual molar mass by the empirical formula's molar mass. So the actual molar mass was 92, while the empirical was 46. I get this number 2, and then step 3 is going to tell me what to do with that number. Step 3, we want to multiply the empirical formula subscripts by the answer from number 2. So if my formula is NO2, I'm going to multiply everything in my formula by 2. So that gives me my molecular formula of N2O4. Now if we wanted to check our work, we can do that by taking the molar mass of N2O4, and we end up with 92 grams per mole, which is exactly what we were looking for here. So that's one way you can check your work on finding the molecular formula. I hope this helps you determine the empirical and molecular formulas. When you get to the homework, 5 and 6 are a little different. So I'll leave this here. They don't give you the amount of bromine for 5, and they don't give you the amount of oxygen for 6. So we have to do a little bit of subtraction here. And that'll allow you to get the grams of oxygen and the grams of bromine for 5 and 6. All right, good luck. Hope you learned something. Goodbye.